Hi, my name's Evelise, and I'll be talking about methanotrophs. Can they be the key to tackling greenhouse gas emissions? Global warming. It's a term we have all heard of before. It refers to the gradual increase of Earth's average temperature resulting from the release of greenhouse gases into the atmosphere, which traps heat like a blanket, causing the planet to warm. This can lead to disruptions to the ecosystems, which could lead to extreme weather events and scarcity in food and water in the future. Two of the biggest greenhouse gas culprits are carbon dioxide and methane. Carbon dioxide contributes to roughly 60 to 70% of global warming, with methane contributing to 20 to 30%. Although methane is second to carbon dioxide in contribution in greenhouse gas related climate change, methane is estimated to be 28 times more potent to that of carbon dioxide in trapping heat in the atmosphere. Greenhouse gas impact. So, why is this of importance? As more and more greenhouse gases are released into the atmosphere from the burning of fossil fuels, industrialization, and human activity, it leads to what is known as a positive feedback loop, where the initial change is warming, which triggers another change that accelerates the rise in temperature, leading to additional warming. The change triggered would be the melting of the Arctic ice and permafrost. The Arctic is warming 2 to 4 times faster than the global average. It's estimated that 1.7 billion metric tons of carbon dioxide and methane is stored in the permafrost, which is roughly 51 times more than the carbon dioxide released by fossil fuel emissions. So we can see how this could be an alarming issue. So that brings us to methanotrophs. What are methanotrophs? Methanotrophs, or specifically methanotrophic bacteria, are a diverse group of gram-negative bacteria that can use methane as their sole source of carbon and energy. High-affinity methanotrophs, also known as HAMs, have been found in Arctic mineral soils and the permafrost. Permafrost is made of a combination of soil, sand, sediment, and rocks that are held together by ice that stays completely frozen for at least 2 years straight. The melting permafrost accounts for 20 to 25% of methane emissions, and the HAMs in this permafrost oxidize 20 to 60% of this methane before emission to the atmosphere. The HAM's ability to create these methane sinks make methanotrophs a big interest in studies for natural mitigation strategies. Mitigation of greenhouse gas emissions is crucial in order to reduce global warming, and coming up with new mitigation strategies is at the forefront of handling climate change. Studies have shown that certain strains of methanotrophs, such as the M. buriens 5G-B1C, has become a promising candidate for methane removal technology due to its ability to exhibit greater methane consumptions at both low and high methane levels compared to other methanotroph strains. There are current limitations to the use of methanotrophs in such a manner such as the oxygen and methane concentrations required for survival and growth. However, scientists are trying to find a way to genetically engineer methanotrophs to be more resilient. More studies need to be conducted on a larger scale to see their overall effects on creating global methane sinks. The use of methanotrophs, though, offer a promising, sustainable, low-cost potential avenue for curbing greenhouse gases. Just makes us think, what else is tiny but powerful hiding in the soils beneath our feet that could potentially solve such a huge problem like this? Thank you.